All right, so recording. We're gonna do question 17, all right? Question 17 has the same question at the beginning. It says, simplify the expression, all right? So we're gonna simplify this thing over here. And the first thing we want to do is recognize there are some properties of the exponents that we can apply to this question. Even though this question has a root, we can apply some properties to the exponent first. What I mean by that, is, look at this. Over here we have an exponent to the 9th power, and then an exponent to the first power, and they have the same base. So you can simplify that thing, right? Same thing with the y on top and the y in the bottom. You can simplify. What I mean by that is, look at this, is since we are not doing anything to the root, I'm gonna leave the root the same. Okay, I'm gonna leave the root the same, but the exponents, since they are dividing and they have the same base, you can just leave the base and subtract the exponents. So 9 minus 1 equals 8. Did you see? Same with the y. They are dividing, right? They have the same base, so you can leave the same base and subtract the exponents. 7 minus 3 equals 4. And now, once we had a horrible question that had a fraction inside the root, but now no fraction. And look at this. Every exponent can be simplified with 4. What I mean by simplifying is you can just do x, and a divided by 4 is equal to 2. 8 divided by 4 equals 2. And then 4 divided by 4 equals 1. So y to the first power. And I'm not going to write the first power because we all know I can just leave it like that. This is the final answer. All right. Now, in case you didn't get why I am doing the division I'm doing, let me show it to you over here. What I'm doing here is jumping, finding shortcuts. Let's call it that way. I am finding shortcuts. Instead of having to do x to the 8 and separating the 8 into 4 and 2, and then separating the y. No, I don't have to separate the y. Instead of doing that, I am just doing this property. Look, the first property I told you about, a to the m over m is the same, a fractional exponent, as the m root of a to the n, right? So you can apply that here. You can just say that x, let me do it backwards. You can just say that the fourth root of x to the 8th power, the fourth root of x to the 8th power, which is the first part, right? Is the first part. This can be expressed through this property. This root can be expressed into a fraction. You just need to leave the same base because a was inside, so a becomes the base, right? Leave the same base, and the exponent will be, look at this, n over m, n over m. So the exponent over the root. So in this case, 8 over 4. And 8 over 4 is a division we can do. This is the reason why I divided a divided by 4. This thing will be x equals 2. Did you see, guys? That is the main reason, okay? Now, that property is absolutely beautiful, and it helps us a lot, but only when the exponent and the root can be easily divided. If they are not easily divided, we have a decimal here, and that sometimes can give us mistake. It can be mistakes. It can be done, but sometimes it can give us mistakes. It can make things a little bit harder. So yes, I advise you to use this property, the division of exponents, only when the exponents can be divided. Same thing happened here. Look, if you were to do the division, 4 divided by 4, that equals 1. There we go. Okay, let's take a look at the chat and see more questions. 17. Cata Castro, how do you do number 15? Juan Sebastián Parrao, is the same like in the 15? All right, let me see number 15 then. Because 2 people are asking for number 15 now. Yes, exactly the same then. Who was the first person? Number 15. Cata Castro. Look, number 15 is a question that starts right over here, right? Sure, with a different root and then some different values for the exponents. But it's exactly the same. All you have to do is divide the exponents and the roots, and you're going to have the answer, all right? So give it a try, Cata Castro. Give it a try, all right? If you still cannot do it, write it in the chat, and I'll do it in the board for you, okay? All right, let me see more questions. Sophie Gonzalez, how do you do number 23? Number 23. Oh, number 23 is good. Number 23 is good. Let me show it in the board for everybody. 23. Okay, question number 23 says, simplify the square root of 5 by the cubic root of 9. But all of this is going to be elevated to the second power. Look at that. Man, that looks hard. That looks hard. How can we solve this? Absolutely simple. This thing is absolutely simple. It looks hard, but it is absolutely simple. Here is how. Remember the property I told you about? Remember the property that when I said the end root of a number is the same than the end root elevated to the exponent. So I told you you can change the exponent inside and put it outside of the root. Did you remember that? Well, you can apply this root here, but backwards. You can apply it backwards. Instead of having the exponent in the outside of the root, you can just leave it inside of the root. Here happens here is what I'm saying. The square root, the exponent square, right? These two over there can be put inside each of the man, I can't speak today, sorry. Inside each of the roots. There we go. And the reason to do that is to, once the exponent is here, we can cancel it with the root. Because here is a square root, right? So by having the 2 as an exponent and the 2 as a root, we can cancel those and the final answer will be 5 of this part. Did you see? And by doing the same with the second here, we can make this 9 into an 81. And the cubic root of 81 is a lot easier to find. I hope. All right, let's do this. By doing this, if I want to put the root, the square, inside the exponent inside of the roots, I need to distribute them on this root and also on this one, right? So I'm going to have the square root of 5 to the second power by the cubic root of 9 to the second power. Did you see what I did? I distribute the exponent into the 2 roots. Now I can put it inside. So I will have 5 to the 2 and then a square root by 9 to the 2 and then a cubic root. Did you see that? Beautiful. Now we can cancel things. 5 and the root get canceled just like we wanted to. So this is a 5. Look like an S, sorry. And now we need to solve this thing over here. 9 to the 2. How much is 9 to the 2? Well, 9 to the 2 is 81. 9 to the 2 is 81. Let me just write it here. 81. But this number, this 81, can be expressed into a multiplication that we can cancel with the cubic root. This is the multiplication I am talking about. This looks like an S, sorry. 5 by 81 can be expressed as 27 by 3. If you do this multiplication, look, 3 times 7, that's 21. So leave the 1 and carry 2. 3 times 2 is 6, plus the 2 is 8. You see? So 27 by 3 is the same as 81. And why did I leave it like this? Because the cubic root of 27 is a number we know. Here, they are asking us for what number do you multiply by itself 3 times to get 27? 3. 3 by 3 by 3. 3 by 3 by 3. This is 3 by 3 equals 9. By 3 equals 27. So we know the cubic root of 27. This thing is 3. So far we have 5. Looks like an S. Sorry, man, I can do my fives today. 5, there we go. By the cubic root of 27, which is 3, by the cubic root of 3. There we go. And now we can multiply these two. 5 and 3 can be multiplied, right? They are outside of the root, so I can do that multiplication. I couldn't do this multiplication here because there is a number and there is a root. I can do that multiplication, right? That is not one of the rules of mathematics. You cannot just multiply these two. Or you could, but just by leaving it that way. 5 by the cubic root of 80y. Right? But in here, the multiplication is a lot easier, a lot simpler. 5 by 3. That is 15. So 15 times the cubic root of 3. This will be our final answer. There we go. Great question. Thank you for asking. Who was that? Sophie Gonzalez, thank you for asking. All right, let's see. Let's see about more questions. Daniel Felipe Osorio, number 15. Yes, buddy, we did it already. 21. Tomas Ramirez, 21. Let me see the question. Number 21, number 21, number 21. Here it is. Okay, it is kind of the same, but I can see there is a difficulty, so let me change it. Let me do it for all of you. Number 21. All right, the question says, simplify the following expression. And it is the square root of 3 times x squared, right? By the square root of 12 times x. Beautiful. Okay, how did you solve this question? Let me change to the chat. Maybe you guys are asking this. All right, how did you solve this question? Absolutely simple. You're going to solve each root individually. So first solve this root, then solve the second one. And at the end of that, try to multiply the things that can be multiplied. So what I mean by that is, look, the square root of 3 cannot be done, right? We don't know it. It cannot be simplified. But we can simplify the square root of x to the 2. The 2 and the 2 gets canceled. So in the first root, we have x outside of the root and inside of the root a 3. Because again, we just canceled the x, but the root has the 3. We haven't canceled or we haven't simplified anything with involving the root and the 3. So we're going to have to leave that like that, right? Let's continue. How about this part over here? The 12th root of x. What can we do there? Well, this 4 can be expressed as 4 by 3, right? And we can simplify the square root of 4. We can simplify that thing, right? So remember, since there is nothing, there is a multiplication, so I'm going to leave the multiplication here as well. If we were to do the root of 12, we were going to have to do the root of 4 by the root of 3. And the root of 4, we know it. The root of 4 is 2, right? The root of 3, we don't know it. Let me just write it over there. The root of 3. And we also have the root of x, which we haven't simplified. We haven't canceled anything because there is no exponent there, so there's a 1. So we can just leave it like that. All right. So now let's try to multiply the things that we can multiply. Look at this. We have a multiplication here. Square root of 3 times the square root of 3. How much is that? How much is the square root of 3 by the square root of 3? All right, the square root of 3 by the square root of 3. For someone who likes mathematics, this thing can be solved, can be made into an exponent, right? Into a power. Because you have the same base. A times A equals A squared, right? Since these two are the same numbers, we can have the base, square root of 3, and then to the 2. Did you see? Square root of 3 times the square root of 3 equals the square root of 3 to the 2. And this can be cancelled. In other words, square root of 3 by the square root of 3 equals just 3. And we can take that, we can use it because we are multiplying these two roots over here, right? So in other words, we have an x that we haven't done anything with times 2, which is this one, and then times 3, which is the solution of square root of 3 by square root of 3. And also we have a final square root of x, which is this one over here that we haven't done anything with. Did you see, guys? Final solution. 2 by 3 equals 6. And rewriting the solution, let me just erase this thing over here. Let me just erase it real quick. All right. The final solution then will be 2 times 3 equals 6, right? Rearranging this solution will be 6 times x, which is this one over here, times the square root of x. And this one will be the final simplification of our question. All right. Let me see more questions in the chat. Oh, but 10:02, guys. That means we're going to stop doing questions here, right? If you want to advance a little bit more into this, you can ask me for a tutoring, and I'll help you with this. Okay, guys? I'm going to stop recording right now.